Okay, so this is the frequency detection test. This is for the frequency sensor hardware side of the equation here. So everything is running at full capacity, including the wireless. So noise is absolutely maximized right now. And basically what I have here is a capture of the screen. You can see that that's the waveform. The things that we're concerned about here is these voltage levels measured by cursors. That they were not within the triggering things, so you see 1.42 volts and 4.2 volts. We're outside of that. The rise times and fall times are very sharp. You can see they go straight up and down. There's no hysteresis on these. I can actually adjust the sections per division here to show that there is no, I guess it would be ringing, which would cause multiple interrupts and causes a whole bunch of trouble. So that's that part, and then for the rest of this, I'm going to change gears here and take a look at the actual process here. So what we have coming out of here, right out of the transformer, we actually have over here on the oscilloscope, we have a pretty big wave. And the problem with this is I couldn't find a transformer that would bring it down far enough, so what we did is we did a high resistance value voltage divider, which brought it back down to much more manageable. Come on now. There we go. Peak-to-peak voltage of 700 millivolts or so. And what that does is it goes in and that ensures that it's large enough to trigger the comparator to make the frequency generator signal. But what we were concerned about is when we plugged it into a 240 volt source, how if that was doubled basically, that it wouldn't go over the 5 volts, so that we wouldn't have a whole bunch of noise dumping into our 5 volt line and messing up the rest of our circuit. So that is exactly what we were looking for as a result, anywhere around 1 volt, and that's perfect, and that should complete the frequency generator test.